Hi guys, welcome back. This is a question which is redundant connection. Very interesting question. And many of the other questions are related to this particular problem. So we can solve this. In this problem, a tree is undirected graph that is connected and has no cycle. You are given a graph that is started with a tree with n nodes and labeled from 1 to n with one additional edge added. The added edge has two different vertices and was not an edge that was already existed. The graph is represented as an array of edges of length n, and edges of I, that is A and B, indicates that there is an edge between the nodes A and B in the graph. Return an edge that can be removed so that resulting graph is a tree of the nodes. If there are multiple answers, return the answer that occurs in the last in the input. Okay, so basically, what is this redundant connection? Okay, they have this given a graph, right? 1 to 2, 2 to 3, and 1 and 3. They have given this graph. They are asking us check whether there is a cycle or not in this particular graph. If there is a cycle, then remove the redundant connection. That means remove this redundant connection. See, if you see, there is a cycle between 1, 2, and 3. And that's the reason they are asking us to remove 2 and 3, or to remove the redundant connection, which is at the last. So, just to make you understand, we have to find the edge which is like causing the cycle. Okay, that is the question all about. We have to find the edge which is causing the cycle. If there is no cycle, then we are not going to return any edge. Okay, we have to check cycle is present, then return that particular edge, which is called as a redundant connection, or the connection which is not necessary but it has been made. Okay, now let me tell you how to do this. See, we can do this question in O of n square. Okay, very easily we can find out with the help of DFS method. But more easier way to do this question is with the help of union find. And why we are going to use union find, that also I'll let you know. And the time complexity of union find is O of n. Time complexity of union find is O of n. Now, let me tell you, one thing is for sure, that whatever number of edges, right, you have, suppose there is two edge that and there are two nodes, then there is a cycle. This is must. Or else, if there are four edges and four nodes, then there is a cycle. That is must. Okay, same edges, same nodes, you are going to have a cycle. I'll tell you the reason. One, two, three, four. There are four nodes, right? Now let's make an edge over here. Let's make this edge one edge, two edge, three edge, and four edge. There is a cycle, right? We don't need this edge actually because it's causing a cycle, right? So if anyhow you take it, if you rub this edge, okay, let me have this kind of an edge, then still it is a cycle, because you see they are creating a cycle. This is creating a cycle, right? Let's rub this and just try to be more smarter and just have the edge in this direction. Then also it is a cycle, right? Then also it is a cycle. Let's become more smarter, and this time we'll rub this thing and try to do a different edge. Let me show you how we can do it. Still you will see that there is an if there are same number of nodes and same edges, you will still see that there is a cycle. Suppose 1 2 3 4, right? Then if like you can create this, right? This is how many edges? Three edges. If I draw any line over here, it's going to create a cycle. It's going to create a cycle. So whatever four edges, four nodes and four edges, it's going to give you a cycle. And at that moment we have to remove the redundant connection. Now, what is redundant connection? Let me tell you why are we using union and find algorithm over here. Okay, let's try to do this. Okay, Why are we using union find? Let's take this example, right? This is the example over here. So we have this edges, right? One, two, three, all right? These are the edges over here. Or let's take four also. Don't take this example, because first I'll tell you why to use union find. One, two, three, four. Okay. Now, now the thing is, I am connecting edge 1 and 2. I'm connecting what I'm doing. Basically, I'm doing a union. When I'm connecting any node, I'm doing a union. So first thing, I'm doing a union operation, right? I'm trying to union it. I'm connecting 2, 4. I'm connecting 3, 4, right? This is all what I'm doing is union. Now, when I'm connecting, suppose 1 and 3, when I'm connecting 1 and 3, that at that time what I'm trying to search is, what I'm trying to find is the parent. See, 3, it is not necessary to connect 3 with 1, because 3 is already connected to 1 in this fashion, right? I mean, 3 is already, if you go from here, right, if you go from here, 3 is already connected to 1. 3 is already connected to 1. So you don't need this particular edge at all. You don't need that edge at all, but still you're connecting. That means when you're finding, what you're finding the root of that particular node. You're finding the parent of that particular node. And then you're saying, okay, 3 is already connected to 1. Then why this edge is present over here? That's the reason we call this as redundant connection, which is not necessary connection, but still we are connecting it. It is called redundant connection. So basically, we understood this edge as a redundant edge with the help of union find. So first I did a union, I did a union. Okay, we are still good. But when I'm trying to union this 1 and 3, I understood 3 is already connected to 1. 3 is already having the parent. Then it is not a necessary job that I have to connect again 3. And question says that yes, you have to connect 1 and 3. That means 1 and 3 is a redundant connection. It is a redundant connection, and you can give this as an answer. This is a little bit why we are using union find. Next, we'll check how to solve this particular question. Okay, so to solve this union find, they have given us the edge, that is, these are the edges. I'm not going to okay, let me, because I have a less space. Okay, let's the question be over there. We have one, two, three nodes. Okay, and we are going to have parent array, and rank array. These are arrays, and these are a size of the edges. So parent array is having edge 1, it is having edge 2, and it is having edge 3. And rank is the size of the parent, but values are 1. What is rank? Basically, what is rank? Okay, let me tell you, rank means size or parent. Rank means its weight or the size of that particular node. So what is the size? So what is the size of this particular node? This size is 1 only, because it is not connected. So the size is 1 only. It is connected to itself. So size is 1 only. This 2, it is connected to itself. So size is 1 only. That's the reason I have given the size of that particular node as 1. And these parent arrays are nothing but the nodes 1, 2, 3. Now the first edge, they are telling us that union 1 and 2, right? What are they telling us? They are giving the edge 1 and 2. So I am going to perform the union operation. Before I'm going for a union operation, what is a formula that I have to check the parents? Okay, I have to check the parent of 1, I have to check the parent of 2, and I find it that they are having the parent of itself, because rank is 1. Rank is 1. That's the reason. I mean, the parent, they are parent of itself. So I can union them because they are parent of itself. I can union them. Now, how to union them? Whether I should connect 2 to 1 or I should connect 1 to 2. You can connect any ways. You can connect any ways. There is no issue, because you are, because both of them the size is 1 and 1 only, so you connect to 1 and 2 or 2 on 1, it doesn't matter. You So now I'm going to connect this 2 over here. Okay, when I'm connecting 2 to 1, right, I'm connecting 2 to 1. Now the rank of 2, now the parent of 2, what is the parent of 2 is not itself. Parent of 2 is not itself. Parent of 2 is 1. Parent of 2 is 1. So in the parent array, wherever there is 2, I am going to make this as 1. I'm going to make this as 1 because parent of 2 is going to become 1. This is for your understanding purpose, like what I'm trying to explain. Parent of 2 became 1. Now, once the parent of 2 became 1, did you know what is the size of, what is the rank of 1? See, parent of 2, 1, right? What is the size of 1? Here, now the earlier, the rank of 1, size means rank, okay? When I'm saying size means rank. What is the rank of 1? When before starting this question, the rank of 1 was itself, the parent of 1 was itself, so the size of 1 is 1 only. But now since 2 is connected to 1, the rank of 1 is increasing, so rank of 1 became 2, right? Rank of 1 became 2, so rank of 1 is increasing because one he got one connection, so definitely it is increasing. Next, so I did the union operation so far. What in a union operation I did it? I just verified first. I just find the parents first. First I did the finding operation of parent, and then I did the union operation, right? I found that what is the parent of 2, what is the parent of 1, and then I connected this edge, and then I increased the rank of 1 because it has got one more connection. Okay, now next age is 1 and 3. Let's take the 3 and 1 edge. Now here, first we have to do the find. What is the parent of 3? 3 is parent of itself. Who is the parent of 1? 1 is parent of itself. Now once this is done, let's check the rank. Let's check the rank. What is the rank of 3? Rank of 3 is 1. What is the rank of 1? Rank of 1 is 2 because it has connection. So it makes sense that 3 should get connected to 1. 3 should get connected to 1. So now, because whatever the higher rank, right, we are going to give the edge to that particular node. Higher rank node will get the edge. So now the 3 is connected to number 1. Now the rank of 1 is again increased as 3, and parent of 3 became 1. Parent of 3 becomes 1. So you can see that first thing is I found the parent of 3. When I say the parent of 3 was itself, and then I went to 1, one parent is also itself, but after that I went and find the ranks. In the rank array, I saw that rank of 1 is 3, and that's the reason I union 3 with 1, because whichever is the highest I am going to do the union. That's how I'm doing union as well as finding. Union and finding. What finding? Finding the parent. What union? I'm doing a union of the edges after finding the parent. Next edge is 2 and 3. Here comes the catch. 2 and 3, right? Now let's find out the parent of 2. I go over here because we are doing a find operation. Parent of 2 is 1. Let's find out the parent of 3. Parent of 3 is also 1. Both edges is having same parent. Both edges are having same parent. That means if I connect 2 and 3, there will be a redundant connection. So if an edge has the same parent, that means there is a cycle. And if there is a cycle, we are going to give this 2 and 3 edge as our answer, because that is the one which is causing redundant connection. That is the one which is causing redundant connection. Because there is a cycle, parents are same, and that's how we give this edge 2 and 3 as our redundant edge. and time complexity is O of n. Explain you in the code over here. Basically, I had created a union find class wherein I have the n parent, and you don't need this number of components. This is not essential. And I'm iterating the for loop, and I'm for the parent, I'm giving the ith number, the index, and rank of I is 1. So this I is actually 0, but we are going to ignore that 0. Then we are going to find the parent. Here we are finding the deepest root of the parent, because we need the grandparent, right? So that's the reason we are going to create the deepest root of the parent. For example, 4 is the node, 4 is connected to 3, 3 is connected to 2, 2 is connected to 1. So we need the one parent, the deepest parent. That's why we are finding the grandparent, and we are doing that with the help of a while loop. And then we are doing a union over here, where we see if the parents are same, if n1 and n2 edges are same, then we find the cycle, and that's why we return the false, because whatever is cycle, we have to return false. And whenever rank n2 is greater than n1, then we are increasing the rank array, and then we are assigning those parents according to the rank. That is what I am doing over here, and the same class I'm using in our um, function, that is redundant connections. And I'm again finding the edge 0 and edge 1. Once I find that edge which has the same parent, then I'm returning that particular edge. Otherwise, I'm doing the union of edge 0 and edge 1. This is what is about union find algorithm. Thank you for watching.